Hello, everybody, to the webinar Days for Construction Materials of the Werder Scientific Group. This is the first day and the first event from ELTRA, and we are happy to welcome all of you. So this is the schedule of the webinar days today and tomorrow. We'll start now with the ELTRA webinar about quality control, followed by the presentations of our sister companies REG, Carbolite, Gero, and Microtech MRB about sample preparation, furnaces, and particle characterizations. Of course, my colleagues would also be happy if you would join them for the webinars. Later on, we'll give you some information how to proceed with that. But first of all, before we start with the webinar, I would like to give you a very brief introduction into the Werder Scientific Group of companies. We are a group of 5 companies. All of us produce high quality products for the analysis and for the science of solid materials. Carbolite Gero produces furnaces and stuff for heat treatment. REG is into milling and sieving. Microtech MRB is in particle sizing and particle characterization. QATM is in hardness testing and materialography, and we, ELTRA, are experts in elemental analyzers. Our first presentation today will be about the quality control by elemental analyzers in cement production. And I'm sure a couple of guys of you have already experienced there. We will have a small poll later on. And if you should have some questions during the webinar, it could be very specific questions about ELTRA or other companies. It could be general questions or comment. Please use the box with the questions and we will get a reply either at the end of the webinar, we can talk about it, or you can get a reply by email later today. Okay. Who are we? ELTRA is a company expert in elemental analyzers and located here in Germany in the western part between the cities Cologne and Düsseldorf. We are founded in 1981, so next year we turn 40, we turn 40, and our portfolio is elemental analyzers for carbon, sulfur, hydrogen, oxygen and nitrogen, and thermogravimetric analyzers to detect moisture, ash, and volatiles of solid materials. We are located, as I said, in Germany and very specifically in Hahn. And right now, during the webinar, we are exactly behind this windows. And luckily, the weather is as nice as it's shown on the pictures here. We have a beautiful September day in Germany. Okay, but now let's start with the presentation about cement, specifically Portland cement. Portland cement is has been patented as a method in the 18th century, in the 19th century by Joseph Espin, and ever since it has grown to the most important building material in the world. As a fact, it is a mixture of limestone and clay or shale, and this was like that 200 years ago as it is today, but of course everything has been very much developed ever since. While the starting materials are the same, like limestone and clay and sand, the process is much more controlled than it was before. Here is a scheme how cement is done with limestone and grinding, with the heating in the kiln, and subsequently the product which we have as final product here. And we have indicated some E at those stages where typically elemental analyzers is performed using ELTRA analyzers. So I will not go too specifically into the production of cement. I'm sure most of you guys who attend here are more expert about this than we are, but I'm going to continue with the topic of quality control and elemental analyzers. So we are performing quality control in raw materials like the limestone, the clinker, is tested with elemental analyzers, and of course it is used for emission regulations, which is getting more and more important these days. Talk about CO2 footprint as well as sulfur dioxide emissions. Then it is also used to optimize the process in the furnaces. The fuels and secondary fuels which are used in furnaces need to be optimized for the process, and elemental analysis is not only useful there, but it's absolutely necessary to make sure that the process works as it should. Some of you might be familiar with the loss on ignition method used there, but of course there's a much faster way to detect carbon contents in those materials. So I'm starting with carbon and sulfur. One of the products in cement product injection which is used for elemental analysis is the clinker itself. ASTM defines the cement as a mixture of clinker and other materials like calcium sulfate, gypsum, and some additives, but 90% of the product is clinker. So we can say that the production of cement depends largely on the proportion and quality of clinker itself. Such it is really important, thus it is very important to control the quality and make sure that we have a product there which is of good quality and which fits the demands. Besides clinker, we have some other fillers. Most important is probably the limestone. It's cost saving, up to 5% is limestone, and the calcium carbonate content of the limestone is mainly made of calcium carbonate, is not very constant. It can be as low as 80%, but of course, to ensure production quality, it needs to be fixed. So the test of limestone is one of the main tasks of elemental analyzers in cement. Further, we have gypsum, which is used there, and the gypsum control the set time for the cement, and it has to be taken care because too much or too little of the gypsum would affect the strength of the cement as well. And then, of course, we have the final product. Portland cement is available in in several types, and all of them have different properties. And the type 1, 2, 3, 4, and 5, they have different compositions. And what I'm showing here is specifically the SO3 content of those types of cement that we have. So we can see that with an increasing amount of sulfur of SO3, the long time strength of the cement decreases, which means low SO3 content means usually high resistant Portland cement, like the type 5 has only 1.8% of sulfur trioxide, while the moderate resistant has 2.5, and the one which is less resistant, the type 3, has 3.1% of SO3, meaning that this is an effect on the stability of the long-term stability of the cement itself. So it is important to make sure in the final product that the SO3 content is controlled and meets the specification of what cement producers sell to their customers. And the elemental analyzers using combustion analyzers is the most effective and the most accurate method to detect those limits. And my colleague Andrea Theisen will show you very soon which ELTRA analyzers we can use to control the SO3 content in the cement. But first, I will go into another topic where elemental analyzers is really important, the fuel. The fuel for the kiln is usually some organic fuels like coal or coke or heavy oil, and the higher the carbon content is, the more energy we get, the more heat we can get, and the production, for the production of clinker, we need in temperature higher than 1450 degrees, and to reach that, the fuel must be very well selected and controlled in order to receive those high temperatures. So the first of all, it is important to test the fuels like coal, petroleum, coke, and heavy oil, but also what we call secondary fuels, which is of course price attractive to use, but also they will burn and they will demand some testing to make sure that we can get enough energy, enough heat when we burn them. Not only the carbon is important here, but also very important is the sulfur content. Why? For emission. The amount, the sulfur emission is a minor concern for during the clinker production. There also we have a little bit, but it's not that much. But it's a big topic when it comes to the energy, because we have a high amount of emission there, or potentially high amount of emission. By controlling sulfur content in fuels, this can be limited. So this was a brief overview of cement production and where ELTRA is used. And next in line will be my colleague Andreas Theisen, our sales director, who will tell you more about the ELTRA analyzers in the elemental analyzers of cement. Before I pass to him, we will have a quick poll, which will be shown now to you.
Okay, thank you very much, Khan, for this nice introduction, and thank you very much for your comment here in the poll. And we see that it's more or less 50-50. So 50% work already with an elemental analyzer and 50% do not work. So in the next part, which will be the main topic, will be our elemental analyzers. I will explain you a bit which type of elemental analyzers can be used for cement, and also why we have different types of elemental analyzers for cement, so that you get an overview about what we are offering you for your daily work. So the first thing I want to talk about is the so-called loss on ignition. This is a bit misleading word, but it is more or less what we have in the literature. This is a word which was mainly a phrase which was mainly thought for coal, where you really ignite something. Cement, of course, you don't ignite, but nevertheless, this is the phrase we have in the literature. So what you do is you take your sample, your cement sample or limestone sample, it doesn't matter, and then you stepwise you raise the temperature, and during the temperature raise you look at the mass of your sample. And you have different temperature where different things happen. So of course, first in the range of 100 degrees centigrade, water moisture is coming from the sample. There might be even a second step in the region of 200 to 300 degrees if you have a lot of gypsum, for example, in your sample, where you lose the crystal water. So you have a next step there. Then we have organic matter. I come later to this again, the so-called TOC or other things which can really burn in an oxygen atmosphere. And then we have the carbonates coming, for example, from our limestone, which is not exactly at 1000 degrees centigrade, but it starts somewhere beyond 550 degrees. And losing the CO2 will also result in a loss of weight of the sample. And this is done by thermogravimetry, which means that we have an instrument which has a furnace and a balance. We will see on the next slide. And for example, here you see if this is clear, if you have a high loss on ignition, if the mass loss during this heating process is high, so which means that you have a high value of moisture or prehydration or carbonation in your sample or in your storage. On the next slide, we see how such an instrument looks like. So we have it here. This is the furnace part. So this here is the furnace. Here you see the heating elements. This furnace can heat up to 1000 degrees centigrade. And here we have our crucibles. And in this crucible, you put your sample. Here is the balance. This here is the pedestal of the balance. And then this table turns, and every time when a new crucible comes during the turning process, we look at the weight of the sample, the mass of the sample, and we do this in several steps. You see it here in this graph. Here you have the temperature steps, 100 degree, 550, and 1000 degree. And here you see the loss on ignition, the loss on heating up your sample. So the first step is moisture. The second step here is then the TOC content, and then the last step is here. When we go to 1000 degree, we see CO2 coming out of the samples. And these 19 samples are tested simultaneously, which means you don't need a muffle furnace or something like this. So you do this, everything you do in your thermogravimetric analyzer. And with this analyzer, you can automatically determine the LOE, the loss on ignition, of up to 19 samples without any attendance from outside. You see here, for example, the crucibles where you put your sample in. We have them ceramic. Sometimes it's better to use metal, depending on how aggressive your cement is. If it has a very high SO3 content, you might prefer metal crucibles. And the weighing cell, this is also important, is encapsulated, so it does not come in connection. It does not see the gases coming out of your cement, especially SO3. So this gives you a very long time stability. And the carousel itself is connected over a ceramic spindle. You can have it in ceramics, you can have it in metal. So there is a lot of options for this depending on the type of cement you are looking at. The main part, what is ELTRA doing, is the combustion analysis. And combustion analysis means that you heat up your sample in an oxygen stream. And we see this here, for example. We have here our CSD. The D is for dual carbon sulfur analyzer with a dual furnace. So we have two furnaces inside this analyzer. So a 2-in-1 combustion analyzer with an induction furnace and a resistance furnace. The detection method itself is the same for both type of furnaces. So it's infrared detection, which is the most common method for this type of samples. Be aware, when I come later to the standards we are talking about, be aware that some other analytical analyzers use different detection methods which are not part of these ASTM or ISO standards. Look careful that your analyzer fulfills the standards. And IR detectors, they always fulfill the standard because they are part of all main standards which are connected to cement measurements. We have gold IR cells, which is important if you have an aggressive atmosphere, and you always have with cement, because SO3 is coming out of your sample, or SO2 is coming out of your sample. We can measure 2 ppm up to 100%, which is a very broad concentration range. We saw in the introduction of Kahn that mainly we have more or less for cement always the same concentration range we are talking about, which makes your instrument cheaper in this discussion, because we don't need 4 RR cells, we only need 2 in this case. We are compliant to all relevant international standards, and what we also can do is a fractional analysis. If you want to measure the total organic content in your sample, sometimes in cement you have organic content, might be some cellulose or whatever, then you can measure these 2 with our instruments. And we even have one instrument which is not part of this presentation, because this would need too much time, which concentrates on measuring this TOC content in cement. So if you are interested in this, not only in the total carbon or total sulfur content, then we have also solutions for this. How does it work? So we have 2 furnaces. Why do we have 2 furnaces? For most samples, the resistance furnace is sufficient, and the resistance furnace is also ideal for your fuel, for the fuel you use in the kiln. So especially, for example, for your secondary fuel, the resistance furnace is used. You know, resistance furnace, you have a tube and there is a wire around the tube, more or less easily spoken. And with this, you heat up the tube. Maximum temperature is 1500 degrees centigrade. Additionally, we have an induction furnace. This is this part here. You know, induction oven from your kitchen might be, and the induction furnace has some advantages. The main advantage is the higher temperature. You see more than 2000 degrees centigrade. And this cracks really everything in your cement sample. Some sulfur bondings inside your sample, inside your cement sample, are very, very strong. And if you have the suspicion that your sulfur content you measure is too low, then try it in the induction furnace. And if you get a higher content there, then you see that the bonding is too strong for the resistance furnace. There are more tricks and tips. Even in the resistance furnace, we have special chemicals we can add to our sample, that we get a higher temperature, or that we get more oxidation power. So if you have the suspicion that there is something with your sulfur content, if it is the variation is too high, you can contact us and we can give you a lot of tips and tricks for doing this. So the ideal solution for a cement plant is the induction furnace combined with a resistance furnace. And the nice thing with the CSD is that these 2 furnaces, they share one detection system. So you only have to buy one detection system for 2 furnaces, and you don't need 2 analyzers to do this. How is it done? The operation is very easy. So what we need is the initial mass of our sample. Because it's a relative method, we always refer to the initial mass. You need a balance. You put your sample in the crucible, then you start the furnace via software, and then the crucible heats up. The gases come out. The carbon might burn, or the carbon might come out during CO3. Carbonate is decomposed by the heat inside your crucible. CO2 is coming out, and then you measure it in the infrared detection system, and the results are calculated automatically by the software. The analysis time for the induction furnace is very short. It's 40 to 60 seconds. Yes, it's like in your kitchen. If you work with an induction furnace, induction oven, it's much quicker compared to the good old resistance furnace. And in the resistance furnace, you see it here, it's always on temperature. Induction furnace in between goes down to room temperature again. And in the resistance furnace, the sample comes in the hot furnace, and the sample is burned there, or CO2 is coming out there. And as I said before, the main difference is the lower temperature. But also here, everything is controlled via software. There are some advantages of our new furnace design. The CSD was launched last year, so it is state of the art. And we put all our experience in, for example, the small amount of excess oxygen assures that no atmospheric CO2 is coming inside. We have an optimized diameter of the sample pod, and we have a lot of more, especially the temperature stability, a lot of more features now in our resistance furnace, which is state of the art of modern resistance furnace analyzers. Here you see some results. Here you see the reproducibility, and this is a really very good reproducibility, for example, here for CO2, for SO3, which you measure during your experiment. So you measure CO2 and SO3 parallelly. You get the result with one measurement. And here, for example, we have 5.3 plus minus 0.05. And here we have for the CO2. And for the sulfur trioxide, we have 3.10 plus minus 0.04, which fulfills all standards, SOP, or whatever you can imagine for measuring cement samples. As I said before, this is important. Always look at the standards which are important for your kind of measurements you are doing. Here are some standards. You see, we have a lot of standards where elemental analyzers are mentioned. Most are for steel or coal, but we have also a lot of standards where limestone, for example, here, or where cement is mentioned. And look in these standards, look which type of furnace and which type of detection method is mentioned there, so that you are sure that you fulfill these standards, because your customer will ask if you fulfill the standards later. I'm coming more or less to the end of my presentation. I want to show you here with this slide that we not only have analyzers for cement, of course, but here, for example, we have an oxygen, nitrogen, hydrogen analyzer for metals. So if you have any question regarding with elemental analyzers, you can come to us, not only connected to cement questions. We have a lot of brochures which explain our analyzers, but also we have a lot of publications which are exactly focused on, for example, cement analysis or other analyzers. And you see it here, we have also a lot of publications where we do not only focus on the analysis itself, but also, for example, on sample preparation. Because you will, if you join later the REG seminar, you will learn that sample preparation is much more important to get good and reliable results than the analysis method itself. We have application notes. So what you get is more or less a cooking book for your type of analyzer and for your type of sample. If these application notes are not sufficient for your problem, you can call us at any time. You can send us your samples at any time, and we will make a special application note for you. So we do not only sell analyzers, but for us it's very important that we have satisfied customers. So we care for every customer and every application he's dealing with. Coming to the end of this seminar, I want to focus you on future webinars we are doing. So if you like these kinds of webinars, come regularly to our website. You see, normally it's enough to look at the news at the news page of our website, and there you see the webinar. So this is our third webinar we are doing this summer, and there will come more webinars in the near future. And the last slide I have now is how can you contact ELTRA? And this is also important. It is not only that ELTRA here in the headquarters has a fully equipped laboratory, but also worldwide. He's also attending. Our colleague in India, Mr. Subbarao, for example. These are our colleagues in China, our colleagues in, South Africa. Our colleagues in, this is Germany. Here we have our colleagues in France, and here we have our colleagues in the USA. So we are all over the world present to deal with your samples, to deal with your application, and to deal with your question. Thank you very much for joining the webinar. In between, my colleague Mike, he already answered in the chat some questions. Mike, are there any questions where I can comment on now? Because the time is almost over, I think.
Yeah, hello from my side. I hope you can hear me. I answered already a couple of questions. There might be some one question which can be interested. Andreas, we were talking always about carbon and sulfur. It's a question if we can give the customer also the CO2 and SO3 results as well.
Yes, we can, because in cement industry, normally you don't talk about carbon content, but you talk about CO2 or SO3, or some people do about SO2. This is easy, yeah, because it is only a calculation. Yeah, if you have it, the carbon content, you can easily calculate from the carbon content the CO2, the CO3, the SO3 or SO2 content. So this is done via the software. So the software calculates for you any content you would like to have from the initial carbon or sulfur content by having a fixed factor, because it's only a matter of molecular mass of SO3 compared to sulfur itself.
Okay, yeah, thanks everyone. There are a couple of other questions which I couldn't answer right now, but I will come back to you later. So we saved all the questions, so don't worry. Since our colleagues from Reg wants to start their webinar in a couple of minutes, again, if you're interested, you can still register for it and take part of it. It will start in about 20 minutes, 27 minutes. Thank you for attending also from my side. And yeah, if you have further questions, don't hesitate to still send it. We will answer it.